Okay, here is the 9-3B classwork number 30 help video. Here we have the function y equals 3x over quantity x plus 2 squared. This is different because it's a quantity squared, it's a 0 squared. This is going to make our asymptotes, our behavior around the asymptotes act weird. But same thing as usual, we're going to go through and make sure we identify all these landmarks before we try to graph. Okay, so let me move this back over. Where are our holes? I don't have any common zeros. I just have a 0 at 0 and -2. So there are there's none for the holes, in other words, common zeros. How about the vertical asymptotes? Where are the vertical asymptotes? Well, there's only one 0 of the denominator. It's at x equals -2, but it's squared. Again, that's going to make our asymptote behavior weird. So at x equals -2, there's a vertical asymptote. What about horizontal asymptote? In this case, there is one. We have x as first order and x squared if you multiply this out. So the degree of the denominator is greater. That means y equals 0 is our horizontal asymptote. Okay? And this is one where the graph will cross over the horizontal asymptote, but the end behavior, it will act correctly. Sometimes you can cross over a horizontal asymptote, but not near the end behavior, that far right or far left of the graph. Now let's see if there's any x-intercepts. Where are the x-intercepts going to be? Well, that's a 0 of the numerator. In this case, it's only a 0 on the top, so if I plug in this value, what's a 0 that makes this quantity 0? Well, it's x equals 0. And that becomes our x-intercept. And, lo and behold, if I plug in x is 0 here and here, 0 over 4 is still 0. So that means this point does, in fact, hit the origin as our x and y intercepts, and that makes it kind of easy to graph. All right? So we graph this, draw our axes, arrows only go on the axes. So there's no holes. I got a vertical asymptote at -2. Okay, y equals 0. The x-axis is a horizontal asymptote. I do this like diagonal slash line like that to show that. And then the origin is a point on the graph. So I know the graph goes through there. So you're thinking to yourself, wait a second, that point is on the asymptote. I don't know if the branch is going to be top right or bottom right. Well, now we have to do something, the old number analysis thing. Let's choose a point way over here like 10. Let's see, 10, if I plug that in there, it's 30. 10 plus 2 is 12. 12 squared is 144. Both of those numbers are positive, so this number is up here. It's a fraction, but it's something like that. So I know all the values over here to the right of this 0 are going to be positive, but it does not go like this because it has to go through this point right here. Let's try -1. Sometimes you have to plug in some points to get an idea. If I plug in -1, I get -3. -1 plus 2 is 1. 1 squared is 1. This point is at -1, -3. So this part of the graph is going to go like this, cross over the horizontal, go up a little bit, and then back down that way. I hope that makes sense on why that behavior, you cross over the horizontal asymptote in the middle of the graph, but not at the end. Let's check over on the left side of this asymptote. Let's try -3. -3, if I plug that in there, I get -9. -3 plus 2 is -1 squared is +1. Aha! So because when all the x values are negative on this side, that's going to keep the numerator as a negative number, but when I square whatever it is, it's going to become positive. So that means all these numbers, it's down here at -9, all these numbers go like that for that part of the graph. Again, because I have a 0 that's quantity squared in the denominator, that makes our behavior around our asymptote quite weird, and you have to plug in some numbers to see what makes sense so you find out how to sketch your graph.